Hello, Longhorns. I have decided to do something a little bit different. I am using the completed key as my backdrop for this video instead of writing it in new and fresh. So while I have this on the screen, I want to go ahead and scroll through so that you can check your answers with this key. I'm going to go ahead and go over the problems that are most like the ones on the test, and hopefully this will help you prepare for the test on Thursday. So let's start with question number 1. All right, question number 1, it says simplify and state the excluded values for each. All right, so the first thing we need to do is take a look at the rational expression that we have. You want to see if there are any factors that you can factor out of each term before you start. In the numerator, we have a common factor of 2, so we want to factor that out first, and we're left with n squared minus 5n minus 24. The next step is to go ahead and factor this trinomial. So the two numbers that multiply to give me -4 that add to give me -5 are -8 and +3. So this is that completely factored. And now what I want to do is see if I can factor the denominator. And since I don't have any values here that I can easily factor, I'm going to have to use either the box method or the grouping method to factor this. Here I used the box method. It's the same as the grouping method, it's just in a different format. So 3 times -8, that's 24. I could have put a negative sign here, but I chose not to. Then you find the factor pairs that are going to add to give a -23. Well, that's going to be -24 and +1. So I wrote those in my box. -24n and +1n. When I combine these two values together, they equal -23n. Then what I do is I factor out of each box. So through here I'm factoring out the n. Through here I'm factoring out a -8. So n minus 8 is one of my factors. My other factor is going to come from this direction. So here I'm factoring out a 3 and an n. And here I'm going to factor out the +1. So as you can see, I wrote these down here. 3n plus 1, n minus 8. And so the next thing I'm going to do is cancel anything that the numerator and the denominator have in common. So I'm going to eliminate those. So n minus 8's eliminate. And what I have left is 2 times n plus 3 over 3n plus 1. So you can write your answer in this form. This is fine in the factored form, or you can write it in the standard form. So if you go ahead and multiply the 2 through, you get 2n plus 6, and the bottom, the denominator is just 3n plus 1. So either one of these is acceptable. I'm not going to count off if you don't put it back in standard form. If you leave it in factored form, that's fine. That's just fine. And now let's go on to the next problem. Okay, in the next problem, we're going to simplify each and state the excluded values. This is problem number 3. So again, we're going to be factoring any place that we can. Here I can factor out a 5. I can factor this trinomial. I can also factor this trinomial. So that's what I've done right here. I get 5 times n minus 1 for this one. For this one, I get n minus 6n plus 4. For this one, I get n minus 10. Now this one's a little tricky because you can see it's written backwards. So if I wrote this in the right order, it would be -n squared plus 2n plus 24. So what I've done here is I factored out the -1 so that I would have this. If I factor out the -1, I have n squared minus 2n minus 24. And then I factored that, and I got n minus 6, n plus 4. Okay, so now what I'm going to do is just cancel out any of the numerator and denominator terms that are alike. So n minus 6 gets factored out, the n plus 4 gets factored out, and then what we have left is 5 times n minus 1, which is 5n minus 5. And we have n minus 10 in the denominator. And we also have, remember, we factored out this negative 1, so we keep that negative sign in the front. And that's all. The only thing I did not do on here that I need to do is state the excluded values. Now, the excluded values are anything that makes the either one of these denominators equal to 0. So that would be 10 here. That would make that equal 0. Also down here, I'm going to look here and I'm going to say, well, 6 minus 6 will make that equal 0, and negative 4 will make that equal 0. So those are my my three values that are going to be excluded. So 10 is excluded, 6 is excluded, and negative 4 is excluded. So we're going to call these excluded. And that's it. Now you may get a problem on the test that says state the excluded values. So you still have to do this work in order to figure out which values are going to be excluded, but you don't have to do all of the elimination that there is in this problem. So basically, once you have factored the denominator, you'll have all of your excluded values, and you don't have to really work the rest of the problem out the way this is. That will save you some time. So please read the directions and make sure that you're not doing a lot of extra work and spending a lot of extra time doing tasks that you don't need. So for example, if I do number 4 and I've factored everything, factored the top and the bottom, to get the excluded values for this particular problem, all I have to do is look at the denominators. So I'm going to look here first. This right here, if that's a 0, then the whole thing is 0. So I know that 0 is going to be one of my excluded values. The next I'm going to look at is the b minus 7. If the b is 7, then this is going to be 0. So that's going to be another one of my excluded values. And then the last one I see that I need to eliminate or exclude is this one right here. Now, if this b is a negative 6, that's going to make this equal to 0. So I need to exclude also negative 6. And these would be my excluded values. And you don't have to do the rest of these eliminations and simplify, because it didn't say simplify. It just said state the excluded values. So on the test, I'm going to be looking for this right here, these excluded values. That's what I'm going to be looking for. And I'm going to be looking for this right here, that you factored the denominator to find the excluded values. That's what I'm going to look for on the test. All right, so here's another problem, problem number 5, where it says state the excluded values for each. See how it does not say solve or simplify? We're just stating the excluded values. So the main thing you need to look for here is there's a couple things that are happening. First of all, in the original division, we have this expression right here that's going to get flipped, but we still have to include it in our excluded values. So in this one, we're going to be including anything that makes any of this equal 0, plus anything that makes any of this equal 0. So you have to factor everything first. And see, with this one right here, what I did was I rearranged this to negative v squared minus 2v plus 8. And then I factored out the negative 1. You see what I did right here? And I rearranged it. So I factored out the negative 1, and it gave me v squared plus 2v minus 8. And then I factored that. So that factors out to v plus 4v minus 2. Then I have to multiply by the reciprocal. So I had to flip it over. So what happens here is now this one is also going to have to be included in my excluded values, along with this v plus 4, v minus 2, which was already excluded anyway. So we have -5, -4, and 2 in our excluded values. And that's all we had to do. We didn't have to rewrite it or simplify it. Just find the excluded values. So we do the exact same thing for problem 6. The only thing I wanted to point out that might be different for this one is in your equations right here, you've got some common factors that you could factor out of this first, and you probably need to do that before you decide what's going to be excluded, okay, because this can be factored. So you want to make sure you factor that first. So we factor out a 3x and we get 3x times x plus 3. And that right there tells us that 0 is going to be one of our terms, one of our values that we need to exclude, and then -3 also. So I've got both of those listed here. In addition to those, we have to include this -1 and this -3. So we have a -1, -3, and that's it. Those are our excluded values. All right, problem 7 says simplify each expression. So we have two fractions here, and the first thing you want to do is look to see, well, is there anything I can reduce before I start working on this problem? And if you notice right here, this is 6a minus 3a. Well, that actually reduces to 2. So I can actually reduce that. 6a over 3a, I can reduce that to 2. And that's where I got this 2 right here. Then I need to say, well, I know I have a 2 over 1, but my denominator's not the same. I have a denominator of 1 and I have a denominator of 10a minus 2. And so I need to get a common denominator. So to get the common denominator, you have to multiply the first fraction, which is 2 over 1 now, since we simplified it, times 10a minus 2 over 10a minus 2. That's the denominator for this fraction right here. So we want these two things to be the same. So if in order for this to be the same as this, I need to multiply this 1 by this term. And then I also need to do the same thing to the numerator so that I'm not changing the value of my fraction. All right. Now the next step is to go ahead and combine these. So I combined them. I got 20a minus 4, and then I also have an a plus 2 all over my common denominator of 10a minus 2. Then I simplified. 20a plus a is 21a. -4 plus 2 is -2, all over my common denominator of 10a minus 2. And that's my final solution. So that's the final expression simplified. The next problem we're going to do is problem number 9. It's also a simplify problem, but you need to be careful because this one has, guess what? It has a negative. So be careful about that. Okay? So the first thing we're going to do is look at our two fractions to see if there's anything we can reduce. And we can reduce things in both of these fractions. In this fraction, I can reduce the x. So I go ahead and take it out, and that leaves me with 2 over 3. Over here, I can factor these, and when I do, I get 3 times 2x minus 1 over 3 times 5x plus 3. This is how it factors. And what's cool about this is that helps me eliminate some values, so I can eliminate the 3. So the next thing I need to do once I've done that is find my common denominator, because these denominators are not the same. This is a 3 and this is a 5x plus 3. So to this fraction right here, I'm going to have to multiply the numerator and the denominator by this fraction's denominator, which is what I did right here. And then with this fraction, I have to multiply its numerator and denominator by this denominator. Well, that puts that 3 right back that I just factored out, doesn't it? But that's okay. Don't worry about that. If you get the steps right, that's the important thing. All right, so 5x times 2 gave me the 10x that I have here. And then 3 times 2 gives me this 6 right here. Then I have minus. Now be very careful right here because this is a minus 2x times 3. So minus 2x times 3 is minus 6x. And this right here is minus a negative 1 times 3. So be careful. Now see how I left the parentheses here? I left the parentheses here for a reason. Because when I multiply everything through by this negative, the signs are going to change. So that's important. Be careful of these double negatives. So I have 10x minus 6x is 4x. And then 6 minus a negative 3 is 6 plus 3. That's going to be 9. And then my denominator is just the common denominator that we created. 3 times 5x plus 3. And that's this right here. So that's our final simplification. And we're done with that one. Okay, problem number 10 is another simplify problem. And so we are going to first reduce whatever we can. So in this fraction, I can reduce the 2 and the 6. I can reduce that to 1 over 3. And the r over r squared, I can reduce that to just r. And then I have minus r minus 6 over 2r plus 1. I can't reduce anything here, so then I'm going to go to the next step. So the next step is to multiply this fraction, the 1 over 3r, by this fraction's denominator. So top and bottom. And I'm going to multiply this fraction's numerator and denominator by this denominator, 3r. So we have r minus 6 times 3r and 2r plus 1 times 3r. Now be careful with the double negative again. Here we have another double negative. So watch out for that. All right, so here we have our combination. So we have our 2r plus 1 minus 3r squared plus 81r. That's what we get when we combine all of this. And in the denominator, we have our common denominator of 3r times 2r plus 1. So negative 3r squared plus 20r plus 1 over our common denominator. Or you could write it like this, where you write it in standard form. This is factored form. I don't care what form your answer's in as long as it's correct. All right, so for problem 13, this one is solve each equation. Remember to check for extraneous solutions. All right, so the first thing I need to do is multiply each term in my equation by the greatest common multiple of the denominator. So the greatest common multiple of the denominator for this problem is going to be the 6n plus 5. This one has a 6n plus 5. This one has a 6n plus 5. This is just 1 over 1. So this one needs to have, this one is going to have to be multiplied by the greatest common multiple, which is 6n plus 5. So I multiply this term by 6n plus 5. I multiply this term by 6n plus 5. And I multiply this term by 6n plus 5. So what ends up happening is the 6n plus 5's cancel. And then I just multiply the 1 times 6n plus 5. And that's what I get right here. So I have 6n plus 5 plus this 1 equals this trinomial, 5n squared minus 20n minus 25. The next thing I want to do is combine like terms. So that's what I've done here. I've combined like terms. And when I combined the like terms, I got 5n squared minus 26n minus 31 equals 0. Well, then I had to factor. So I did the box method. Now you could do box method or you could do grouping. It doesn't matter. I prefer the box method. For one thing, it doesn't take as much space, and for another thing, I just like it better. But if you like to do grouping, go ahead and do that. It doesn't matter to me which one you use. All right, so I put my 5n squared in this box. I put my minus 31 in this box. And then I multiply those two numbers together and I get 155. Then I'm looking for the factor pair that when I multiply them together, I get negative 31. But when I add them, I want this middle term here of negative 26. So negative 31 plus 5 gives me a negative 26. So that's what I'm going to use for my middle terms. So negative 31 times 5 gives me the 155, but the negative 31 plus 5 gives me the negative 26n, which is my middle term. Okay, then I factor out of the boxes. This one, this way we factor out an n, this way we factor out a 1, this way we factor out the 5n, and this way we factor out the negative 31. So this 31 needs to be negative, this one needs to be positive, and those are going to be my two factors for this trinomial right here. Okay, so here they are, 5n minus 31, n plus 1. So when I solve for n, I'm going to set these both equal to 0. Solve for n. For this one I get 31 over 5. Add 31, divide by 5. This one I get negative 1. Now, it says look for extraneous solutions. So to get the extraneous solutions, you want to see what value for n will make the denominator equal to 0. Do I have any values that make the denominator equal to 0? Well, if I set this equal to 0, I'm going to get a negative 5 over 6. If one of my answer choices was negative 5 over 6, that would have been an extraneous solution. But I didn't, so both of these solutions are good, and we're finished with this problem. Okay, I used the same technique to do problem 14. I found my greatest common multiple, and I multiplied each one of my terms by the greatest common multiple. In this case, I went ahead and factored out this 3k from here. So I got 3k times k minus 4. This one was also 3k times k minus 4. And this was 3 times k minus 4. So this one didn't have the extra k. So I went ahead and multiplied all of my terms by this 3k times k minus 4. And then I just eliminated everything they had in common. This one, of course, we need this k. Here they both just cancel out completely. This one cancels out completely. So what I'm left with after I do all of this cancellation, I'm left with k squared. This k times this k is k squared. Then k times a negative 2 is a negative 2k. Then I go to the next thing, which is just my 4, so plus 4 equals, and then just the k plus 4 on this side. Now I combine like terms. Well, these 4's are going to cancel out, because when I subtract 4 from 4, I get 0. Then I'm going to subtract a k from both sides, and I get k squared minus 3k, because I have a minus 2k minus a k is a minus 3k. So I get k squared minus 3k equals 0, and then I factor that. When I factor out the k, I get k and k minus 3. Well, one of my zeros is going to be k is equal to 0, and the other 0 is going to be k is equal to 3. Well, if I look back at my equation, k can't be 0, because if k is 0, then I get a 0 here in the denominator. If I plug a 0 in here for this k, this is going to equal to 0. So 0 is extraneous. So we cannot include 0 in our solution set. The only answer that's going to be in our solution set is the number 3. Okay, so now we're off to complex fractions, and simplify each expression is the next thing we're going to do. And problem number 15 is similar to the one that's on the test. So the first thing you want to do is focus on your numerator. Okay, simplify that first, then simplify your denominator, and then do the division. Okay, that'll make it a little bit easier to do this. So we're going to look at the numerator first. Well, my numerator right away, we don't have a common denominator here, so we can't add these fractions together. So the very first step is to take care of that. So I'm going to multiply this fraction by this one's denominator. So that's how I got this a plus 2 times a plus 2 over 3 times a plus 2. So that's my new fraction. And then on this side, I need to multiply this fraction by this one's denominator. So times 3 over 3. So I got 4 times 3 over, and now I have a common denominator, 3a plus 2. So here it is. So I can combine these. I get a plus 2 times a plus 2 plus 12 over 3 times a plus 2. So this is going to be my numerator. See, that's why I put num here. This is my numerator. So I'm going to leave it in factored form. I'm not going to multiply these together because I might be able to eliminate some things here in a minute. So I don't want to change that just yet. I'm going to leave it in factored form. The next thing I'm going to do is I'm going to do the same thing with my denominator. Well, see, what's cool about this denominator is it already has a common denominator. So you have a common denominator with a plus 2. All you got to do is add the terms together. So 4 plus 6 is 10. So the next thing I do is I got to flip that. Here's my 10 over a plus 2. That's my denominator. Okay, so the next thing I need to do, because it's a division, this is divided by, I have to flip this one. Here it is flipped. A plus 2 over 10. And now I can eliminate, and this is why I left these in factored form, because now I can eliminate stuff. So I can eliminate this a plus 2 with this a plus 2. So those eliminate out. That helps simplify things a little bit. Now I went ahead and combined this, multiplied it together using FOIL, and I get a squared plus 4a plus 4 plus 12. All right, and that's all over 3 times 10, which is 30. Okay, so let me move this over a little bit. And so my final answer then is a squared plus 4a plus 16, okay, because 4 plus 12 is 16, over 30. And this is my final answer for this simplification. So we simplified all of this stuff all the way down to just this. Now we're going to look at problem 16. Okay, so for problem 16, we are going to, once again, find a common denominator for this numerator. So the common denominator is going to be 4x squared. So I multiplied this fraction by x squared over x squared, and I multiplied this fraction by 4 over 4. That'll give me this common denominator of 4x squared. All right, so when I multiply all this together, I get 5x squared plus 100 over 4x squared. The next step is going to be to take care of this denominator. So this one, these two fractions don't have a common denominator, so of course we have to take care of that. So 2 over 2 times 3 over x plus 5 over 2 times x over x will take care of that. Now we have a common denominator of 2x. This is 6 plus 5x, here it is, over 2x. Now, this fraction divided by this fraction is our next step. So we have to flip this one over because we have to multiply by the reciprocal. So we have 5x plus 100 over 4x squared times 4x squared, and then times, 2x over 6 plus 5x. Now this 2x and this 4x squared can reduce. So I've reduced it. So I reduced the 2 and the 4 to 2, and I reduced the x over x squared to x. And that's how I got this 2x right here. The last thing is to just combine everything together. So we have 5x plus 100 in the top, because it's just times 1 here. And then in the bottom we have 2x times 5x, which is 10x squared. And then we have a 2x times 6, which is 12x. And this is our final answer. All right, on the last page, we're going to just look at problem number 21. And this one is negative 3x plus 22 over x plus 6 is greater than or equal to 1. And we're solving for the inequality. Well, the first thing we have to do, because this is not set equal to 0, you see this is a 1. We have to move this 1 over, so we do that by subtracting 1 from both sides. Now we have a fraction minus a number, and they don't have a common denominator, so the first thing we have to do is take care of the common denominator issue. So if we multiply this one by this one's denominator, numerator and denominator, we get this. Negative 3x plus 22 minus 1 times x plus 6, because that's x plus 6. And then it's over x plus 6. The next thing we do is combine terms. So we have a negative 3x plus 22. Watch out for this negative. Negative times x is negative x. Negative times 6 is negative 6. If you mess that part up right in here, the whole answer is going to be wrong. So be careful. Okay, then combine like terms. So negative 3x minus an x is negative 4x. 22 minus 6 is plus 16. Divided by x plus 6. And that has to be greater than or equal to 0. That means that this fraction right here has to be greater than or equal to 0. So the next thing we're going to do is find our what our critical points are. So I'm going to set this part right here, I set it equal to 0, plus 16 equals 0, and I solve for x. So I get negative 16 divided by negative 4 equals 4. So 4 is one of my critical points. So I put that one right here. That's my 4. The next thing I do is check the denominator. The denominator's critical point is going to be negative 6, because that's what makes the denominator equal 0. So here I put a negative 6, but notice that my circle here is open. This is an open circle. The next thing I'm going to do is check to see where it's going to be shaded. Is it going to be shaded in or out? So I need to look at this right here. This is greater than or equal to. So this fraction needs to be positive in order for this statement to be true. So I need to make sure that this is positive. So I check. The first thing I'm going to check is the 0. If I plug 0 in for x, I get 16 over 6, which is positive. So since I get a positive answer, that means that in between the numbers is going to be shaded, because that's what makes this statement true. I also checked the outsides just to make sure. So I checked it with the number 5, and I checked it with the number 7. And both of these gave me negative results. So I know that the outsides are going to be negative, so they're not going to be part of my solution set. So the way I write my solution set is like this. So I can write it in interval form or as an inequality. So either way, whichever one you want to use, I prefer this way, only because I know that when you get to pre-cal, that's the way you're going to be expected to write your intervals. So, but if you write it either way, I'll accept that answer on the test. Okay, I'm going to add one more problem for you guys. This is problem number 16 from your homework, and it's similar to one you might see on the test, so I want to make sure that you've got an example of it. It's x squared plus 9x plus 8 divided by x plus 6 is less than 0. Okay, so we got to find where this expression is true. All right, so the first thing you need to do is factor the numerator. So we factor the numerator and we get x plus 8, x plus 1, all over x plus 6. Now we can get our critical points and put them on our number line. So our critical points are going to be negative 8, negative 6, and negative 1. And all of those are going to be open circles because We don't have an equal to here with our inequality. It's just less than 0. So we're going to have open circles here. Open, open, open. Now I'm going to check to see where we're going to have the shaded areas. So I'm going to have several checkpoints here that I'm going to have to check because I have 3 circles that I need to, 3 areas, actually 4 areas. Now I've divided this up into 4 areas. I have an area here, I have an area here, here, and here. And I need to check all of those to see which part is going to be shaded. So I know that the value for this fraction is going to have to be negative. So I'm going to start with the 0 since that's the easiest one to do. And I'm going to plug 0 in. I can plug it in up here or I can plug it in here. It doesn't matter. So I'm going to go ahead and plug it in here because I think it would be easier. So if I plug a 0 in here and a 0 in here and a 0 in here, I'm left with 8 over 6. Well, that's a positive 8 over 6. So the whole thing is positive. So I want that to be negative. So I know that in this region of my graph, that's negative. So I'm not going to shade that part. So now I'm going to check a value in between -1 and 6, -6. And so I'm going to try -2. Well, when I plug -2 in for x squared, I get 4 plus a -18. 4 plus a -18 is -14. And -14 plus 8 is a -6. So I get a negative number up here. Then down here, when I put in a -2, I get -2 plus 6. Well, that's a positive 4. So I get a negative over a positive. Well, that's negative. So since I'm going to get a negative number here, when I plug a number from in here, that's going to be part of my shaded region. Because this is where the negative happens. Oops, this is positive. Sorry about that. All right, this is negative. All right, so the next one I'm going to check is between a -8 and -6, and that's a -7. So when I plug in a -7 for x squared, I get 14. I get 49. So a -7 squared is 49. Then I have a -7 times 9 is 63. So minus 63. So that's going to give me a -14. Plus 8 is a -6. So I'm going to have another negative number here in the top. Negative. And then when I plug in a -7 plus 6, I have negative. And a negative over negative equals a positive. So because this is going to give me a positive, then I know that that part is not going to be shaded because I don't want a positive number. I want a negative number. All right, then I come back over here one more time. I check the -9. I'm going to check that. So -9 squared is 81. -9 times 9 is, again, -81. Plus 8 is 8. And then a -9 plus 6 is a -3. So I have 8 over -3, which gives me a negative number, and that's what I want. So I know this part here is going to be shaded. So how do I write my solution? Well, I have 2 sections that are in the shaded area. So I have -infinity to -8, but not including -8 because it's open. And I also have an area, so I'm going to say union -6 to -1. And that's also going to be an open parentheses because it's open circles. The other way we could write this is we could say that x is less than a -8, or we could also say that -6 is less than x is less than -1. So either way you want to write it is fine. I don't care, as long as you get the correct values in there. However, just keep in mind that, and put a box around your answer too so I can find it. Just remember that when you get to pre-cal, you're going to probably be expected to write it in interval notation. Okay? So that's the end of the review. Good luck on your test tomorrow, and I hope that, or on Thursday, I guess, but just make sure you study, practice, practice, practice. These problems are not easy. There's a lot of room for error on these. Please make sure you practice and that you're prepared for the test on Thursday. Good luck, Longhorns.